Hi everyone, my name's Rob from RobOps, and today we're back with another AWS Fundamentals video focusing on VPC peering. In this video, we'll peer two VPCs, update the route tables and security groups, and then verify that the instances can communicate over their private IPs. VPC peering is a tool that AWS provides that allows you to create private IP connectivity between two VPCs using AWS's network, so resources can communicate as if they're on the same network without going over the public internet. This is especially useful when you want clean separation across environments, teams, or security boundaries. One of the main benefits of peering is network separation within your account. Peering allows isolation across workloads, environments, or teams while still enabling controlled, explicit connectivity between specific VPCs you choose to peer. Similarly, if you have a multi-account architecture, peering enables secure cross-account resource sharing and communication while maintaining account-level isolation for billing, security boundaries, and organizational separation. Finally, if you have regional workloads, peering enables low-latency, private connectivity between VPCs in different regions, allowing you to deploy workloads closer to users for better performance, while maintaining secure, cross-region communication for data replication, disaster recovery, or global application architectures. In the next part of the video, we're going to show peering in action. We're going to have two VPCs with two instances running in each of them. There will be no peering connection, and we'll see how when we attempt communication, it will fail. Then we'll manually add in our peering connection, and then we'll see how we establish connectivity between these two instances. As always, all of the code that I'll be referencing in this video is going to be available on my GitHub page, linked in the description. Now, let's hop over to the code view. Now that we're in the code view, we have some Terraform that's going to help us bootstrap our architecture. If you go to the modules directory, we'll see we have a VPC, an EC2, and a VPC peering module. The VPC module is going to help us bootstrap our VPCs. And so we're essentially going to use this twice to create two distinct VPCs. Our EC2 module is going to help us launch an EC2 instance into our VPC, specifically in the public subnets of each. The EC2 instances themselves will be bootstrapped with a script that's going to run a service on port 8080. And this is the service that we're going to try to communicate with from the other instance running in the other VPC. And so now if I just go to our main.tf, we'll see a few things. We'll see obviously our Terraform initiation, but we also have our VPC module. And so to start us off, I'm actually just going to comment out everything except VPC A and B. And the reason I'm doing this is I just want to set up our network first. And so if I come down here in our peering demo and I go Terraform apply, this should bring up our VPCs. And it says 20 to add, and they're all essentially just VPC artifacts. And so I'm going to click yes and apply this Terraform. All right, so our apply has completed. And now if we look into our console itself, we'll see that we have our demo VPCs. And if I click into them and look at the resource map, we'll see we have a public and private subnet that are going out to our NAT gateway in our private and our internet gateway in our public, which is exactly what we need. Now, essentially what I'm going to go is go over to EC2, and what the next apply is going to do is essentially replicate me going into instances and clicking launch instance, and I'm just going to say app peering, and I'm going to just use the default AMI, and I'm going to put it into our newly created VPCs, and specifically in the public subnet. Now, something that I'm also going to do as part of this is add a user script on Bootstrap. And if you scroll all the way down here, you'll notice this input for user data. And so if you actually go into the EC2 module, we have this user data shell script, and I just paste it in here. And essentially, that's what I'm going to do with the Terraform. I'm doing it with Terraform because it's a lot easier to manage, and we can make sure that we can apply it to both VPCs right away. But effectively, what I'm doing is going through this simple wizard to create a T3 micro and put it in each of our VPCs. And so if I go back to our code view, and what I'm going to do is I'm actually going to scroll down and uncomment app A and app B. And if you're following along, you can just apply all of this at once, but for the purposes of this demo, I'm just going to uncomment this, and then I'm going to run Terraform apply again. And so this should just pick up the new instances here, and it should say 4 to add. And so I'm going to click yes. And now that our apply is completed, we can switch back over to our console. And we can exit out of this menu that we were in and go back to EC2. And we'll notice that we now have 2 instances running. And these are the instances app A and app B. And so they're still initializing, but once they come online, we're going to SSH into the machines and attempt the experiment. So now that our instances are up, we should be able to SSH into one of them. And so if I'm going to click app A, and I'm going to go to the instance settings, and I'm going to click connect. And then I'm going to go just through the EC2 instance connect UI and click connect. And so this is going to establish a connection with my instance. And as you can see, I've come online. And what I want to do here is just check that my script is running. And so in order to do that, I can simply curl my local IP, and we can say hello from VPC A, from instance A, and here's my private IP 10.10.1.200. And so there we can see that our script and our HTTP service is running as we might expect. Now, what I want to do is try to curl the same service running in VPC B. And in order to do that, I'm going to go back to my instances, and I'm going to need to get the private IP of app B running in VPC B. So in order to do that, I can just click the instance and I go to private IPv4 address. And then if I go back to my EC2 instance, all I'm going to do is curl the HTTP address of the private IP on port 8080. And so if I click this, it's going to submit and it's going to attempt. And what we're going to notice, as we might expect, is it's going to hang. And it's going to hang because there's no connectivity between our VPC A and our VPC B yet. And so now what we're going to do is add that peering connection and retry this same command and see if we get different results. So in order to do that, I'm going to go back to my EC2 instance. I'm going to go to VPCs. And if I go down on the left side, you see peering connections. I'm going to click peering connection, and I'm going to click create peering connection. And this is just going to be my peering connection 1. And I'm going to request the peer from VPC A to VPC B, which is in my account, and it is in this region. But like we went over in the benefits, if it's in another account, that's possible. If it's in another region, that's also possible. But here I'm just simply going to select VPC B, and it'll tell you the CIDRs associations, and then I'm going to click create peering connection. Now, before we can actually activate this peering connection, we have to accept it, which is why this modal comes into view. And so if I click actions, I'm going to accept the peering request. It will give you some details to review, and I'm going to click accept. Now, what it also does is prompt you to update your route tables. So now that we have peering established, the curl request will still fail, and it will fail because we don't actually have any routes to communicate between the two VPCs. And so if you simply click here, you can go to modify routes, and we see demo private and public route tables. And so if I go demo VPC A route table, and I go to routes, what I'm going to do is click edit routes. And so we have the local routes here, this 10.10. Our VPC B is on a 10.20 CIDR range. So I'm going to go here, and I'm going to go 10.20.0.0/16, which is the CIDR range that my VPC B has been allocated. And in the target dropdown, I'm going to click peering connection, and I'm going to click the peering connection that I've added. And I'm going to click save. So now in our VPC A public route table, we have a route to VPC B. However, we also need to add the same route to the public route table of VPC B. So I click this and I click routes, edit routes, add, instead of 10.20, I'm going to add 10.10 as this is the VPC A CIDR range. I'm going to click peering, select my peer, and click Save Changes. So now we've established a peer and we've updated routes so that our instances can traverse those routes to connect with each other. Now if I go back to my instance and I curl the 10.20 private IP address of my instance from my 10.10 user, click enter, I will get a response. And it says, hello from VPC B, hostname 10.20.1, private IP 10.1.03. And so here we can see that the established connectivity is valid. We were able to traverse our peering connection and connect directly with our EC2 instance. Now that we saw how peering works, it's important to understand its limitations. VPC peering does not allow for transitive routing, meaning if VPC A peers with VPC B and VPC B peers with VPC C, traffic cannot automatically flow from VPC A to VPC C through VPC B, meaning you must create a direct peer from A to C for them to communicate. Now, this is what creates a lot of complexity at scale. As the number of VPCs grows within your architecture, peering requires individual point-to-point connections between every pair that needs to communicate. So connecting a lot of VPCs becomes operationally difficult to manage as your network grows. Similarly, VPC peering does not allow edge-to-edge communication, meaning one VPC cannot use another VPC's edge connections, like a VPN gateway or an internet gateway, which means each VPC must establish its own direct connection to on-premise networks or external resources, rather than routing through a peered VPC's gateway. Now, as you can see here, VPC peering is not the only way to connect your networks. AWS offers a ton of different solutions for a ton of different use cases, and I've created a table here to show you where they're most appropriate. But at a high level, the products that you see here are some alternatives to peering, specifically transit gateways, Cloud WAN, and VPC Lattice. And if you're interested in understanding them in more detail, please comment below and I can make a similar video on each of these products. And with that said, I hope you enjoyed today's video on VPC peering. If it was something that was informative to you, please consider liking and subscribing. It really helps out my channel. And as always, thanks for watching and I hope you have a great week.